Hello everyone, welcome to Chemazon Complete Chemistry. So in this video we are going to solve some questions based on aromaticity which are not so usual. Okay, so these some of the few examples that we are going to see. We have to identify whether they are aromatic, anti-aromatic or non-aromatic. So let us see the first molecule. This is called as cyclooctatetraene. Octa means it is 8-membered ring. Tetraene, cyclooctatetraene, also called as COT sometimes. Okay, so if you count the number of pi electrons here, there are how many pi electrons? 4 pi bonds, so 8 pi electron, and it satisfies 4n pi electron rule. So we might think that it is a cyclic, it is planar structure, 4n plus 2 pi 4n pi electron rule it is following, so it might be aromatic. It is also cyclic. Okay, so it satisfies all the rules for a molecule to be anti-aromatic. So if you write anti-aromatic, the answer would be incorrect. Okay, so for these molecules I want you to first solve them and see what answer you are getting, and then you see the answer. Okay, so the reason behind this is, if you see the 3D structure, okay, it might look planar at first, but when you rotate this molecule, okay, in the ball and stick model, you will find that it has got a tub shaped structure. Okay, and you can see this part. Okay, this part generally it is non-planar. Okay, only these two pi bonds you can see it is in plane, but the remaining part of the molecule is not in plane. So this molecule is non-planar, and such molecules comes under which category? It belongs to non-aromatic compound. Okay, whenever there is an sp3 hybridized carbon present or a part of a molecule that is not planar, then it is going to be called as non-aromatic compound. Okay, moving on to the next molecule. So here again I want you to pause this and solve this for yourself and see whether you are getting the correct answer or not. So 1 2 3 4 5 5 to the 10 electrons. So if you count the total electrons and if you substitute in the 4n plus 2 electron rule, it satisfies the 4n plus 2 Huckel's rule of aromaticity, and you might say that it is aromatic in nature, but again this will be incorrect. Okay, why this will be incorrect? So the reason behind this is, here there is carbon is forming 3 bond, and here also it is forming 3 bonds. So there is one hydrogen here, there is one hydrogen here. So basically there is an electronic repulsion between the two hydrogens, so they are out of plane. Okay, one hydrogen will become above the plane, one hydrogen goes below the plane. Okay, so it is basically non-planar in structure, so it is non-planar, so that will be non-aromatic. Okay, and not aromatic, it is going to be non-aromatic in nature. Okay, so there is one way by which we can make this molecule aromatic. How you can make aromatic? You tie both the hydrogens as a sp2 carbon as a sp3 carbon bridge. Okay, you form this bridge, then the rest of the part, that is this green one, it becomes planar, and then this molecule now it can be called as aromatic because it has become planar. Okay, since both the hydrogens are it is substituted by this bridge, now it is planar, so it will be aromatic. Okay, coming on to this molecule, these two molecules again you count and find out what is the aromaticity. So 2 4 6 8, here also 2 4 6 8, so 8 pi electrons, so it follows 4n pi electron rule, so it should be aromatic, anti-aromatic, sorry, in anti-aromatic. So is it going to be anti-aromatic? The answer is again no. So always remember, the molecules have this tendency to avoid anti-aromaticity, because we know in the stability order anti-aromatic compounds, they are least stable. Okay, then comes non-aromatic, and aromatic is most stable. Okay, aromatic most stable, then in between there is non-aromatic, and the least stable are anti-aromatic compounds. Okay, so why this is not anti-aromatic? So this oxygen or nitrogen, it goes out of the plane. Okay, similar to the one that we see in homoaromatic compounds. The remaining part, this 6 pi electrons, they are in conjugation. Okay, but this part is it behaves like an sp3 hybridized carbon, so that it can avoid anti-aromaticity. Okay, so it is non-planar and it is going to be non-aromatic. Okay, so both of these are what? They are non-aromatic in nature. Okay, now coming on to this polycyclic hydrocarbon. Why it is called polycyclic? Because it has got poly means many cycles means there are 4 different rings. Okay, so now here again if we count 3, 4, 5, 6, 7, 8 pi bonds, so total of 16 electrons. So it again follows 4n pi electron rule, it should be anti-aromatic. So is it going to be anti-aromatic? The answer is no, it is not anti-aromatic. So what is the answer for this? So here this middle pi bond, it is not involved in conjugation, so you don't have to count this. Okay, this is a special case. This molecule is called as pyrene. Okay, so you have to count only the periphery electrons. Okay, they are in conjugation. So 1, 2, 3, 4, 5, 6 and 7. So 7 pi bonds, so total how many electrons? 14 electrons. So now if you substitute this in this 4n plus 2 pi electron rule, 4 3s are 12 plus 2 14. So it is what? It is aromatic in nature. Okay, it is not anti-aromatic, it is going to be aromatic in nature. So these were some of the examples where you if you follow the normal rule you will get a different answer, and in actual structure, okay, if you see the 3D structure or some counting thing, you will find that it is a different it follows different aromatic character. So these type of examples are very important for competitive exams, CSIR, NET, GATE or JAM exam. They ask these type of questions. Okay, and that's it for this video. I hope you have understood all the different types of aromatic compounds and you have understood this video. Thank you.